For aggressive chemical processing environments, it only makes sense to require stringent, non-destructive examination of the clad used to fabricate your pressure vessels and heat exchangers. Automatic ultrasonic testing is used for such demanding applications. Characterization of the bond zone for 100% of clad plate surface areas using automatic ultrasonic testing can provide guarantees of compliance with customer requirements.
The automatic UT bench uses basic ultrasonic principles coupled with software programming and machine encoders. Machine encoders allow for the operators to track back to defects. Software programming generates an A, B, or C scan, depending on what the customer specification requires. All this allows the operator to maintain position, track defects, and make sure that we meet customer specifications. So manual scanning runs the risk of human error. When an operator is running a manual scan, they run the risk of missing the scan path. They miss the pressure that's necessary to maintain contact between the transducer and the plate. That, coupled with more stringent customer specifications and requirements, the automated UT allows for better coverage. It takes all the guesswork out of it. The operators don't have to guess what speed they're running at. They don't have to guess where the defect is located because they can track right back to it.
For our general setup, we'll just usually calibrate off the plate itself, unless specified by a customer, and use a calibration block. Turn the water on, set the boot down, just like you'd set up a manual UT machine, but with 6 different transducers or 8. And we'd set the gates to be able to capture any discontinuities in the metal or any non-bond. We could also set the gates for time of flight, which is capturing the thickness of the plate itself or the materials. We use X and Y coordinates to map out the plate, and then that way when it's finished, we can always come back and catch any discontinuity. It'll track right back to that spot.
So our automated UT system uses 2 gates. Gate A is a positive gate. It's set at our approximate location of our interface. Gate B is a negative gate, and it's tracking the backwall signal. With disbonding, you'll have a rise in the interface signal coupled with a loss of backwall signal. Depending on the customer specification and requirements, it can be on the bench anywhere from 30 minutes to 4 hours. We don't let the machine determine pass-fail. The machine is set up in such a way that it scans for gross defects, but the operator still must go in and verify the actual location of the defect and the extent of the defect. It's valuable because reactive metal inherently runs a higher risk of failure during fabrication. That's known across the industry. NDE is a good way to help mitigate that risk and check for defects prior to fabrication.
Partner with NobleClad today for your clad equipment needs. We have experience producing a broad range of corrosion-resistant alloy claddings that are fully compliant with industry and customer specifications. For further details, visit us at NobleClad.com.